What if I told you that scientists at one of America's most prestigious universities just built a device that completely breaks one of the most fundamental rules of physics that every textbook on Earth teaches? A device that moves electrons, the tiny particles that power every computer, every phone, every piece of technology you have ever touched, without using any electrical power source whatsoever. No battery, no electrical field, no power supply of any kind. Just two beams of laser light. And those two beams of light can aim a stream of electrons in any direction they choose, like a lighthouse sweeping its beam across the ocean. But instead of light, the beam is made of pure electricity. Researchers at the University of Michigan have created a device that enables them to control the flow of electrons through a semiconductor using only laser light. No electrical power source required. This device does something that has never been observed before in the history of physics. And what it means for the future of computers, telecommunications, and artificial intelligence is so profound that the scientists who built it are still trying to fully understand what they have created. Stay right there, because this changes everything. Science Daily. Let us first understand why this discovery is so shocking. For over 150 years, since the days of Thomas Edison, every single piece of electrical technology on Earth has operated on one fundamental principle. To move electrons through a material, you need an electrical field. You need power. You need a source of electricity pushing those electrons from one place to another. This is the foundation of every circuit, every chip, every transistor, every processor ever built. Remove the electrical field and the electrons stop moving. This is not a theory. It is a law of physics, so well established that no serious scientist has questioned it in over a century. The University of Michigan researchers showed they could induce the orderly flow of electrons through a semiconductor using two different colors of light. And by rotating the polarization of the two optical fields, they could also control the direction of the electronic current. In plain English, they aimed a beam of electrons using only light, no electricity required. And the physics community has not fully recovered from the implications of what that means. And here's where it gets interesting. News-wise, if that just made your brain hurt in the best possible way, hit like and subscribe, because what comes next will shock you even more. So how exactly does the Electron Lighthouse work? And why does it break the rules? Let us break it down in simple terms right now. The phenomenon relies on quantum interference, which occurs when two colors of light drive different absorption pathways to the same final state. The light transfers energy to the semiconductor material in discrete quantized packets called photons, which mobilize the material's electric charge carriers. In simple terms, imagine throwing two stones into a pond at exactly the same moment. Each stone creates ripples that spread outward in circles. Where those ripples meet, they either combine and get bigger or cancel each other out and disappear. The University of Michigan team used two laser beams of different colors to create exactly this effect, with electrons inside a semiconductor material. The ripples from the two laser beams line up and amplify each other for electrons traveling in one specific direction, but cancel each other out for electrons trying to move in any other direction. The result is a narrow, concentrated beam of electrons shooting in one precise direction, aimed entirely by light, with no electrical power source needed whatsoever. As the lead physicist Stephen Cundiff explained, the light no longer merely switches the current on, it also aims it. Read that again. Light aims electrons. This has never happened before in recorded scientific history. University of Michigan News, SciTech Daily. The electrons produced by this process travel as what scientists call a ballistic current, meaning the electrons travel along a trajectory determined entirely by their initial launch velocity, like bullets fired from a gun, rather than bouncing randomly through the material the way electrons normally behave in traditional electrical circuits. This ballistic behavior is completely different from how every existing electronic device on Earth works. In your phone, your laptop, your computer, electrons are constantly bouncing randomly off atoms as they drift through circuits guided by electrical fields. It is chaotic, it is inefficient, and it generates heat, which is why your devices get warm when you use them. The Electron Lighthouse produces electrons that travel in perfect straight lines with no random bouncing whatsoever. And the implications of that single difference for the future of computing are almost impossible to overstate. Science alert. The discovery could eventually support technologies that combine optics and electronics, including advanced sensing, imaging, and telecommunications, and may also lead to better ways of transmitting signals between devices and encoding more information within them. But the deeper implications go far beyond telecommunications. Every artificial intelligence system running today, every large language model, every image generator, every autonomous vehicle system is limited by how fast electrons can move. Through silicon chips, the faster and more precisely you can move electrons, the more powerful your AI becomes. If the Electron Lighthouse technology can be scaled up and integrated into next-generation chips, and researchers believe it can, it could produce computing hardware so efficient and so powerful that it makes every AI system running today look like a pocket calculator by comparison. The device has the potential to turn into something that measures different aspects of light, meaning the same technology that controls electrons could simultaneously be used to analyze the light that controls them, creating a feedback loop of optical and electronic intelligence that has never existed in any computing device before. Science. Daily Newswise. But here is what nobody is telling regular people about the Electron Lighthouse. This discovery did not come from a secret government lab. It did not come from a trillion-dollar tech company. It came from the University of Michigan's Lurie nanofabrication facility with federal support from the U.S. National Science Foundation, a publicly funded American research institution, which means the breakthrough that could reshape computing, telecommunications, and artificial intelligence for the next century was paid for by American taxpayers and published openly for the entire world to access. China, Europe, Japan, South Korea, every major technology power on Earth just got access to the same discovery at the same moment. And the race to turn the Electron Lighthouse from a laboratory curiosity into a commercial product is now officially underway. The country and the companies that figure out how to manufacture this technology at scale first will control the next generation of computing hardware. And that race started this week. University of Michigan News. The bottom line is this. Scientists at the University of Michigan just created a device that uses quantum interference between two colors of laser light to generate and precisely steer a directional flow of electrons through a semiconductor without any electrical power source, something that has never been observed before in the history of physics. This Electron Lighthouse breaks 150 years of established electrical theory, opens the door to computing chips that are faster and more efficient than anything that exists today, and could accelerate artificial intelligence capabilities beyond what any current roadmap predicts. The discovery was published on July 16, 2026 in Physical Review Letters, one of the most prestigious physics journals in the world, and confirmed by multiple independent research institutions. The smartest people in technology are reading this paper right now, trying to figure out what to build with it first. Make sure you are one of the people who understood what just happened before everyone else. Hit the like button and subscribe to Future AI Hub, because this story is only getting bigger.